So let's take a look at how weather works as we go up in the atmosphere with height. In a normal atmosphere, in the troposphere, which is the lowest part of the atmosphere, in a normal troposphere, air is going to cool as we ascend higher and higher in altitude. Okay? That's why up at the top of the mountain it's usually going to be colder than it is down in the valley. Okay? In a normal troposphere. The air is going to cool in the troposphere at a standard rate, depending whether it's moist or it's dry. Dry air is going to cool faster, moist air is going to cool a little bit slower, but they're both going to cool with height. Once we get into the stratosphere, the air starts to warm again with height. Then we get into the mesosphere and the air starts cooling again with height. Then we get to the thermosphere and the air starts warming again with height. Weather, for the most part, is dealt with only in the troposphere and the very lowest parts of the stratosphere. Okay? That's all I'm going to concentrate on here. Just remember that as you go up in elevation or altitude, the air is supposed to cool with height. But sometimes it doesn't. Sometimes there's effects of weather that cause it to warm as you go up and then cool off maybe some and then warm a little bit and then cool off depending on where you're at. Okay, but that can all happen in the troposphere. It's not standard, but it can happen in troposphere. It happens all the time. And depending on how much it's warming or how much it's cooling as we go up in altitude through the troposphere, it's going to determine how stable or unstable the atmosphere is. Air stability, when it's stable, generally means that there's going to be pretty good weather. Okay? Air instability can lead to thunderstorms, severe weather outbreaks, unsettled weather. The atmosphere wants to be neutral. Okay? Too much stability, the atmosphere is going to try to make it a little bit more unstable to reach that neutral. Too much instability, the atmosphere doesn't like it either. It's going to try to add some stability to reach neutral. In the United States, there's several different climate zones, and you can pull this map up for anywhere in the world. You can type in Köppen climate classification, or just climate zones of the world into Google. If you're not from the United States, you can type it in and you can see maps similar to this. But we need to understand what the climate zones are where we live. For example, if you live in the coast of California or up in Oregon and Washington on the coast, it's more or less a Mediterranean or oceanic climate zone. It can be moist. It's generally not going to be too hot. The ocean is definitely going to influence the weather around there, and so you're like I said, you're in an oceanic or a Mediterranean climate zone. But if you look at through most of the western United States, you're in what we call a desert or a steppe, semi-arid climate because it's dry. Okay, this year Nevada mountain range there in California that turns into the Cascades and up into Oregon and Washington, they block a lot of moisture from getting into Nevada and the eastern parts of Oregon and Washington, okay, and Arizona as well. Now, the Rocky Mountains are there through Montana, Idaho, Wyoming, Colorado, Utah, portions of Arizona, New Mexico. The Rocky Mountains are there. They're in a mountainous climate zone, and they're going to block any more moisture from getting to lots of the western portion of the Great Plains. But as you get into the central United States, the Gulf of Mexico is going to start playing a role, and it starts to funnel moisture up. So if you look at West Texas or western Oklahoma or western Kansas, you see it can be kind of dry, almost like a desert or semi-arid climate. But you look at eastern Texas or southern Texas, and then up through Missouri, Iowa, into Minnesota, we start getting into climates that are a little bit more humid. We look down at the southern tip of Florida, and it's more or less a tropical climate. Look at where Tornado Alley is. If you don't know where Tornado Alley is, it's basically central Texas through Oklahoma, Kansas, Nebraska, up into the Dakotas even. That's where majority of large severe weather outbreaks happen. Look at where it is on this climate zone map. It's where these climate zones come together, where the semi-arid climate meets the humid climate, okay? Because these climate zones exist, there's going to be some odd weather happening through there because ultimately the atmosphere just wants to equalize. It wants everything to be the same. But it's not all the same. but it's trying to make it that way, okay? And so a lot of time, the most severe weather happens in the central United States, right there where you see the semi-arid desert-type climate meeting the humid climate. So there's many different ways that meteorologists work. It's not really an exact science. We do apply, obviously, a lot of atmospheric science to our work, but we also have to apply psychology and sociology skills to what we do, okay? Depending on what our job is. If we're simply just research, then it's almost all science, okay? But if we're forecasting for the general public or for our clients, it's going to be a little bit more psychology and sociology involved, because we want our customers and clients to act appropriately to what we're saying. So, unlike a user manual for working on your car, there is really no user manual to forecast the weather. That's why you can pull up weather website number 1 and weather website number 2, and they might say different things, okay? That doesn't mean one's necessarily more right than the other. It just means that the formula that they're using to come up with that forecast is going to be a little bit different, okay? It's not an exact science because the weather is so complicated, at least in this day and age, it's just so complicated that we haven't really figured out what A plus B actually equals. So we just say 30% chance of rain, right? Okay, so there's a lot of looking at what's happened in the past and under similar situations and trying to apply that to what we think is going to happen into the future. Okay, a lot of statistics involved. And so in some way, shape, and form, it's a very physical science, okay? Very mathematically based, statistically based. But we have to apply psychology too. If we tell you it's a 30% chance of rain, what does that mean to you? Some people would say, that's what they say every day. It's not going to rain. It's not going to rain until they say 50% or 60%, right? Other people will say, well, 30% chance. Yeah, it could rain. I'm going to go ahead and take some precautions, okay? So we have to try to understand how it's going to be perceived because we want our clients and our customers to react a certain way. If I tell you there's a 30% chance of a tornado tonight, you're going to act a little bit different than I say 30% chance of a thunderstorm, okay, or 30% chance of rain, okay. We know that the general public is going to perceive things differently. We want them to react in a way that's going to be generally in their best interests. The sociology portion of it, if we say it's going to be a 30% chance of rain, what's that impact going to be on society? For instance, if we're talking to farmers, right, and they're trying to harvest their hay fields, okay, and they don't want rain to happen. If we say it's a 30% chance or a 50% chance of rain tonight, that's going to equal dollar figures in their heads, right? Where if I tell you the indoor basketball team that there's a 30% chance of rain tonight, it doesn't make any difference. They're playing inside anyway. Who cares? So what is the impact going to be? If I tell you there's a 30% chance of there being snow tonight, and snow doesn't impact you, then okay, whatever. But maybe your city street sweepers, the snow plows and all that, they need to get ready just in case, right? All right, if there's snow tonight and all the roads are snowed in, then you're not going to be able to get to work in the morning, okay? There can be a loss of money there, okay? So as meteorologists, we have to kind of put all this into perspective and try to figure out the best way to get you the most accurate weather in a way that you're going to understand it correctly and that is going to have the intended impact that's in your best general interest, if that makes sense. It can be very, very complicated and we can't please everybody, but that's what we're working toward.